at this point, we have completely defined the mathematical model in ANSYS, and ANSYS knows how to relate the pin displacements to the potential energy. So it can solve the mathematical model and write by writing the algebraic equations that relate neighboring nodal displacements. And as we saw, this comes from minimization of the total potential energy. Let's get ANSYS to solve the mathematical model. Before I click on solve, let me write out the 6 values that we want ANSYS to determine. So I'll highlight line body, I'll do zoom to fit, maybe zoom out a little bit. I'm just manipulating, I can use these to manipulate the model. I don't really need the ruler, so I'll turn that off. I'll go to view ruler. And so this is at this node. So we have 3 nodes that we have marked out, as we saw. And at this node, we wanted to calculate what we called UAX and UAY, how much that node or pin would move in the x and y direction. This is similarly UBX, UBY, and this is UCX and UCY. So there are 6 values that need to be determined. So you would say this model has 6 degrees of freedom. That's a terminology often used in finite element analysis. And of these 6 degrees of freedom, we know a few from the displacement constraints. So since this is fixed in x and y, that both of these are set to 0. And then since this is fixed in the vertical direction, that is 0. Okay? So 3 of the degrees of freedom are known from the boundary conditions, and ANSYS needs to generate algebraic equations to determine the other 3. So it has to generate 3 algebraic equations. And for instance, we saw that it can generate the algebraic equation corresponding to UCY degree of freedom by writing, by minimizing the potential energy with respect to UCY. And this will give an algebraic equation relating that displacement to UCX and also these displacements. So let's get ANSYS to generate those 3 algebraic equations and to determine the unknown degrees of freedom. So I'm going to click on solve, and if you're praying kind, you can say a prayer before that. So click on solve. In this case, the prayer didn't help. Sometimes I guess that happens. And to see this error, and by the way, this is a dreaded error, the solver pivot error, because it means that it's not able to invert the algebraic equations that is generated. So if I double click on that, I can see the error. I can see the entire error, and it says a solver pivot warning or error has been detected in the rotation x degree of freedom of node 2, which we don't know which one that is. This is usually a result of an in-collision matrix, blah blah blah. And here's a clue: an under-constrained model. Okay, so to troubleshoot this and to understand how to constrain the model, one has to understand the extra degrees of freedom that ANSYS is putting in beyond what we discussed in the mathematical model. I'll talk about that next.